Example 2. We have to show that this iteration formula came from this function. Now the easiest way to do this is, instead of rearranging this to try and make this x or this x the subject and seeing how we can get to this, it's better to work in reverse order. So start with the iteration formula, remove the subscript n and n plus 1, and then rearrange this back to this. Okay, so removing the subscripts and then multiplying by x throughout, and then rearrange, and we have this form. So we've shown that. Okay, now starting with the initial value of 3, and sometimes the initial value is x0, sometimes it's x1, doesn't make any difference. So we put 3 in the calculator, press equals, so it's stored in the answer function. Now we need 4 minus 1 over the answer function, so 4 minus 1 over the answer function. So x1 will be this, and then these need to be written down, and we're solving to 3 decimal places, which means the 4th decimal place must be stable enough for us to round confidently to 3 decimal places, and these values need to be written down. So this is the next x value, so now we're up to x2, x3, and again 1st, 2nd, 3rd decimal place, so we've got a 7 in the 4th decimal place, x4, x5, and we can see that the 4th decimal point is now 0, which means we can confidently round to this value, 3.732, to 3 decimal places. Example 3, we have to solve this equation, so we're going to use a numerical method because there is no algebraic method to solve f of x, which is this, equals 0. So our equation, let's make cos x squared the subject, and now we're looking for this value of x to be the subject. We're trying to get everything into this form, and this is the value of x that I'm trying to isolate. So I want this value here to be the subject, this particular instance of x. So to get rid of cos, we need to do cos inverse on each side, because you got the function cos inverse, and cos will cancel. Or the alternative, which is arc cos, which is what I've used here. They're the same though. You can write cos inverse here in red if you like. And the arc cos and the cos will cancel, leaving you with x squared on the left hand side, like so. And then we need to square root, like this. And then to make the iteration formula, modify this to x sub n, and this will be x sub n plus 1, like this. And this is done in radians. Okay, so the initial value is 1. So we've got brackets, inverse cos, and then 2 minus the answer function over 3. Close brackets, and that's a square root, or to the power of a half. Okay, so x0 is 1, this is x1, you should write these down, x2, x3, x4, x5, x6, to 4 decimal places. So we've got 1, 2, 3, 4. The 5th decimal place is now stable, which means we can round down. So the answer will be 1.1298, and x is an angle, so this is in radians. So let's test the value that we just got with this equation here. Okay, so we have, and it's in radians, make sure your calculator is in radians mode, so 3 cos, and then 1.1298, that's our angle, and you need to put a square inside the brackets, not on the outside, plus 1.1298 minus 2, and that's a really small value, 1.4 something times 10 to the power of minus 4. It's in standard form. In ordinary form, I just convert that. 10 to the power of 0 is 1. This is the value in ordinary form. We do have a rounded value for alpha, so that's close enough to 0. For further practice, try these questions.